AI images. They can now be used to spread misinformation. Gen AI has increased the speed at which disinformation can be created. Many types of scams and fake news are being powered by these types of AI. So to solve this problem, me and my friend Jason made a machine learning model that can classify if an image is human or AI generated. Machine learning is a lot like calculating the slope of a line. You would take in data points, or in this case coordinate points, then you would apply a formula, or in our case like y equals to mx plus b, and you would use this new line to find out new data points and what they correspond to. What we just did is linear regression, or how you might know it, as finding the line of best fit using a linear function. We first try to use logistic regression, which is similar to linear regression, but instead of using a linear function, we would use the sigmoid function. In every logistic regression model, there's a threshold value. The threshold value basically is the middle point of that curvy line. And if an x value corresponds to the y greater than that threshold value, we would classify this as true. If it's less, we would classify it as false. To code our logistic regression model, we first had to find a dataset to train it on. We found our dataset on Kaggle, which is an online source which you can use to find datasets, and our dataset had 80,000 pictures labeled with ones and zeros, ones being AI pictures and zeros being not AI pictures. We then clean our data, which just means that we turned all the pictures to the same size and we converted them from pictures to lists of RGB values, which the computer can then use to process. We then split the data into two sections. The first section is the trained data, which we would use to train the model. The second section is the test data, which we would use to test the accuracy of the model. We then coded our logistic regression model. However, this only scored an accuracy of 63%. And we thought that this was because the image is high dimensional with lots of data points, so the model can't find trends within that data. We then try to use CNNs. CNNs work by scanning over the image to detect edges and lines. The model will then put these detections into a 2D map. Next, the model will shrink down this map, and this will make the model faster and less sensitive to noise. For example, in 2x2 max pooling, we would take the highest value of a 2x2 section and we would put it inside of a smaller grid. Then, the model will feed this data into neural networks, which will do some complex algorithms and output the correct case. If you want to learn more about neural networks and the math behind them, you can watch this video that I've linked below. After we coded our model with only 10 epochs for those who are curious, it got an accuracy of 90%. However, we wanted an even better model, so we did some more research. We then found a recent research paper about AI-generated image detection. After reading the paper, we found that AI images have two different textures: poor textures, where there's less detail, and rich textures, where there's more detail. And this shows an inconsistency in the pixel relations, so the image would not be consistent. Using this new idea, we broke the picture into patches and grouped the poor texture ones and the rich texture ones together. Then, we put these patches into our old CNN model. This received a really good score of 98.8%. We then exported this model into a Google Drive, and then we imported the Google Drive and made a UI using Python's HTML library. This resulted in the web page that you saw in the start of the video. Finally, we gave a presentation at UC San Diego through the Cosmos Summer Program about what our machine learning model can do and how we made it.